Welcome to the Rubicon Quick Start training video. The goal today is to save you the first 12 hours of trial and error by teaching you the two most important skills, making an index and searching. For the compiler, we will use Delphi XE3. For full text search components, we will use Rubicon version 4 from HREF tools. For the database engine, we will use open source Firebird SQL, and for the data access components, we will use IB Express from Embarcadero. All Rubicon editions, even the free light edition, include the IB Express bridge. Rubicon components are helpful in many desktop, web, and client-server applications. This training session focuses on the use case where the text data to be indexed changes rarely. For example, the U.S. rail accident database is updated only 4 times per year. As always with Rubicon, for indexing purposes, each record requires a unique integer key. Certain vocabulary words are used in Rubicon in a special way. These 3 are worth memorizing: text, words, and make. Let's jump into Delphi now and build all demos for the IB Express bridge. This bridge includes 4 demos. We will cover the first 2 in this session, starting with exmake, meaning example make. With a free license, you would compile with runtime packages. With a paid license, you can compile from full source. What you are seeing here is the paid edition of Rubicon. Before we can test any example programs, we need some sample data. You can download the U.S. rail accident database from our website. You can also use a utility in the Rubicon setup folder. The utility downloads actually a tab separated value file, and then imports the data. The details vary depending on which engine and content you choose. For some engines, the databases are downloaded in binary, ready-to-go format. You can run the setup utility multiple times to download different sample formats. If you upgrade or reinstall the Rubicon components, you can safely install into the same location. Your sample data will not be touched. Here we are showing how quickly the parts and Rubicon help sample databases are downloaded and imported. Be aware that if you select the rail accident database in the utility, it can take much longer. If you are using Firebird, just download the FBK backup file and restore it using GBack. All the sample data is saved relative to your Rubicon installation folder. You will find a folder named RB Sample Data with all your files. Okay, now we return to Delphi with the make example. The core component to use has class name TRBMake. It must be connected to 2 other Rubicon components linking to words and text. The specific link varies by bridge, so in this video you will see links for IB Express. All the demos use common shared code. This means they are easier for HREF tools to maintain and a little more difficult for you to understand. After we explore this demo, we will build a make example from scratch, and that will be even simpler. The demos include extra code for reporting details and measuring timing statistics. Don't worry about that too much. Focus on the one line that executes the make component, which is simply rbmake1.execute. This demo has an inherited form which adds the bridge-specific components, in this case for IB Express. Using the Object Inspector, we can see that rbmake1 is hooked up to a cache component, in addition to a text link and a words link. The make text link component is hooked up to a TIB query, and it controls the link to the text that you want to index. To index text on all fields of the table, you just set the Select All property to true. To index specific fields, you customize the Field Names property. The Make Words link is hooked up to a separate TIB query. It manages the creation of the words table. You can put the words table into the same database as your text or keep it separate, depending on how you hook up your query and database components. Index segmentation. When you make an index with Rubicon, you can optionally make a segmented index and control the segment size. This is necessary only for huge tables. The Rail Accident database has only 190,000 records and is not considered huge. We have seen how to build the EXMake demo. Now let's build a make project from scratch. We start with TRB make from the palette. Then we look for TRBM components, focus on Interbase Express, and select a text and later on a words link. Each of those will require a TIB query. For optimal speed, define onMinIndex and onMaxIndex event handlers. You should make these functions return the lowest and highest primary key value for your text. If you're using Firebird or Interbase and you have a generator for your primary key, then you can use that generator to give you the highest value. For extreme user interface, we will add a standard T button to the form and use its on-click event to start the indexing. As with any Interbase Express project, we need database and transaction components in our form or data module. Here we are pointing to the Rail Accident sample database. The final touches are adding a Rubicon progress bar component and a Rubicon cache component. When we run our project, the make component first drops any prior words table from the database. Then it creates a new one, and then it starts to fill in that new one based on what it finds in the fields that you've requested. Depending on the size of your text, the make process could take minutes or hours. When make is complete, we can see that the database contains a words table. Now we get to start on Rubicon skill number 2, searching. First we will look at the search demo for IB Express and use it to learn the most important properties that can be controlled for a Rubicon search. Then we'll build a search project from scratch in Delphi. In the demo, the user interface separates the searching process into 3 steps. Step 1 is just to count and list the primary keys that result from the search. If the result is a large number, you will probably want to give the user a chance to search again instead of attempting to show thousands of answers. Step 2 uses an ordinary query to select records that match the primary keys. And step 3 is an alternative. It uses the Rubicon TRB Matchmaker component to select out the matching records. When you do that, you have an extra option of ranking the results so that the best match can be shown first. Finally, the demo also includes a feature on the Tools menu that lets you compare performance for any 3-word search request. When you install Rubicon, you will have source to all of these demos, so what you will see next is what the search demo looks like when it runs. The first demo tab sheet enables you to select your database engine or file format, plus your database content. We are starting with the original Rubicon 1.0 database, which contains help text about Rubicon itself. The idea was that while you were learning how to search, you could also pick up tips about the Rubicon components and properties. Step 1, counting and getting the list of 59 primary key integers, is instantaneous. Step 2, running the SQL select to obtain unsorted matches, is also very fast. And step 3 on this database is also very quick, less than 1/10 of a second, because the table is so small. Even if we set the rank mode property to RM count, step 3 will feel instantaneous to the end user. Now we are searching against the rail accident database, which is large enough to prove that customizing the onMin index and onMax index event handlers is essential for performance. It will take 11 seconds for the TRB search component to execute. This rail accident database contains data from 1975 to 2012, all combined in one table. Database design specialists would be horrified to look at the structure because 15 separate string fields are used to hold the text rather than one memo field. We are intentionally keeping this bad design, including all the extra fields in the table, because it causes slow performance. The United States Federal Railroad Administration has made this data available to the public in one table per year. For training purposes, we combined all the years into one table. The resulting rail accident table is one of the rare public data sets that contains enough text to be worth searching for a demonstration. Notice that even with this large table, steps 1 and 2 are reliably fast. If we included step 3, it would take an additional 1 to 2 seconds per record to be retrieved by TRB Matchmaker. To recap a little, one of the most important points about designing your own user interface is to make it possible for the user to iterate quickly through search phrases until a reasonable number of matches is found. Make sure that if you're using large tables, you define onMinIndex and onMaxIndex event handlers. These go on the text link component particular to your database bridge. And of course, use rank mode with care because it adds extra processing. You can experiment with the memory limit on the Rubicon cache component. The best setting is going to vary from system to system. Okay, in the interest of scientific fairness, we have put a speed comparison feature on the Tools menu of the search demo. This is to give you a quick way to compare Rubicon searches for 3 search words against an ordinary SQL query for the same terms. Of course, the result set will be slightly different because Rubicon is searching for delimited words, whereas SQL is using a like query. Now it is time to build a search project from scratch in Delphi. The primary component is TRB search. As in the make example, it will be connected to a cache, a text link, and a words link. What we'll do is set the search for property to the phrase to be found, and then we will call the execute method. We start with nothing but a form that has a standard edit box and a standard button. Similar to the make example, 4 components have been added. You can see the standard IB Express database and transaction components, plus a query for the text link and a query for the words link. Note that for searching, these link components do not have make in their class name. These are the correct links to use when searching. They presuppose that the words index has already been made. We hook up the links, and for each one we specify the correct table name. Now we need to program the button to do some work. First we'll add a reminder of what we're searching for into the memo. So we'll just put edit1.txt into the memo. Next, we will work with the actual search component and set the search for property equal to the thing we're searching for, edit1.txt. And then we need to execute the component. That's the main thing that needs to happen. Now, in addition, we need to make sure that the database is actually connected. That always helps. And please note that the first time this runs, it will take a little bit longer. All of the subsequent requests will go very, very quickly once things have been prepared. So we'll just record the number of matches first, which we can get directly off of an integer property on the search component. And we'll just, for readability, add in one blank line after the count. So let's run this project. We'll give it something to search for. Train. And remember, the first request is always the slowest, regardless of the number coming back, in this case 29,000. Subsequent searches are very quick to get their match counts, as you can see. It's much faster to get the answer than to type the question. And it really doesn't matter which words you choose or how many matches there are. The count of matches will come back extremely quickly. This last little bit of code that we're going to type is the diamond that you've been waiting all this time to learn. This is how you get access to the list of primary keys that represent the matched records. This represents stage 1 that we were seeing in all of those search examples. So we're going to show you how to get access to that list, and then you can do whatever you need to do from that point forward, whether that's doing raw SQL to select out the records, or if you prefer to go with the TRB match component, of course you can do that as well. So the trick is you instantiate a TList object, and with that you call a special method on the RB search component, which is called matching locations. You pass in that list, which you've already instantiated memory for, and then that's it. You can loop through the count and work with those elements as you wish. In this case, we're just going to add them onto a string, sort of comma separated, so that you can see them in a show message. But you could loop through this list and do whatever you need to do. The data in the list is the primary key. You can cast it as an integer and there's no data loss. And we'll just break out of the loop after 25 just in case we search for a large list. Let's see if this code will compile and run. Hopefully you are jazzed and ready to try Rubicon yourself now. Just a few more tips for you. There are 2 free editions of Rubicon, Lite and Evaluation. The Lite edition is available in Code Central. It is suitable for educational projects. It supports 4 data bridges, ADO, BDE, DB Express, and IB Express, as you've seen here. Lite licenses never expire. Rubicon Lite can be tested even with the free trial edition of Delphi. It's by far the simpler edition to use. The Evaluation edition is available on our website. It supports the full range of third-party database bridges, including NexusDB, IBObjects, Unidac, AnyDac, and many others. Evaluation licenses expire after 14 days, but you can make yourself a new license to extend the time period. Use www.href.com/unlock to make your own serial number. It will be emailed to you immediately. Thank you for paying attention to this Rubicon training video. We do want to hear about your experience. Contact us on our Rubicon support news group or say hello using live chat during late afternoon in California. If all else fails, have a look at the Rubicon manual. When you have your first search project working, remember to buy your Rubicon license in HREF Shop. That keeps the electricity pumping into our servers, so to speak. Thank you. You've been a great audience.